Okay, we're on section 5.6. I'd like you to begin this lesson by finding x in these three problems at the top. Kind of a warm-up. You don't have to use logs, but if you think you know how to use logs, go ahead. If you want to use another method like guessing and checking, graphing, general knowledge, getting the two sides equal using the power trees like we did in the quiz earlier this chapter, that would be fine. So go ahead and try to figure out what x is in these three problems. With or without logs, it's up to you. So what did you get for A? Jackson? 3. B? 4. C? -2. The 2 would square it and make 16, and the negative flips it to make it 1 over 16. Did you or did you not use logs for this? You did? Some didn't. Okay. If you're not sure how to use a log or what a log is, maybe you weren't here Friday or you were asleep or whatever, we can, by the end of this sheet, by the end of this lesson, you should be able to come back to these and use logs to solve. So those are the right answers. This is the definition of what a logarithm is. It's basically a way of rewriting an exponential equation that you see here. This exponential, whoa, I missed. The exponential equation a equals b to the x power is rewritten as log base b of a equals x. More on that right now. So let's practice rewriting these exponential equations as log equations. So let's go ahead down to the middle. We're under practice, part A. How would this look if we wrote it in log form? Remember, log should have a little base next to it. Should have something here, a big number here, equals another number on the other side. They should all be of this format. A little base, the log of something equals the exponent. Remember, when you log something, you're finding its exponent. So in this equation, 100 equals 10 squared. What's the base? 10. So normally, you would write the base down here. But one of the things that I think we talked about it last week, it was on the board on the side of the room over there. When the base is 10, you actually don't have to write it. That's called the common logarithm. And this is the one that's built into your calculator. So if the log doesn't have a little base next to it, it's understood to be 10. If you write the 10, it won't be wrong. But it's more common to not write it if it's 10. Then, the exponent is supposed to be the answer. So it's going to be the log of 100 equals the exponent. So let's pause for a minute and just make sure that our calculators are all working correctly. And type in log 100. It should say 2. So what it's doing when it's calculating the log is it's actually finding the exponent. When you say log 100, you're asking the calculator, what exponent will turn 10 into 100? Okay? Got it? You're following along at home? We have the log button right over here on the left side next to the 7. So you would hit log 100 and enter. It'll be 2. So that means 10 squared is 100. It's a way of finding the missing exponent. Next one. 49 equals 7 squared. That's a true statement. We're not asking you to solve anything. We're asking you to rewrite it as a log. You need a little base. The log of something equals the exponent. So that's where everything goes. The little subscript is the base. And what's the base in this problem? The base is 7. The exponent is the answer. What you're logging is 49. Because it was, in A, I didn't write the little subscript because it was base 10. And when it's base 10, you don't have to write it. Okay? There are similar cases in math where it's just understood to be there, and you don't have to write it. Like the square root symbol. If it's the cube root, you put a little 3 there. If it's the fourth root, you put a little 4 there. If it's the square root, you don't write the 2. But it is the square root. We just understand. It's very common to take the square root so you don't even write it. Okay? So why don't you go ahead and finish up C and D. All we're doing is rewriting it in log form. Go. Okay, we're back, and I wrote the answers in for C and D. The green one there is C. The log of 0.001 is -3. That's one you can check easily on your calculator. You could just type log 0.001. It should say -3. Remember, when you do this, you're finding 10 to what power makes 0.001. When you see this in log form, 7 squared equals 49. That's how log form is written out. When you say the log, here's the way to say it, by the way. You would say the log of 9 base 81 equals 0.5. That's one popular way of saying it. The log of 9, then you say the little base, 81 equals 0.5. I've also heard people say the log, base 81, of 9 equals 0.5. The key is to say the word base in front of the 81. So you would say this one, the log base 7 of 49 is 2. Practice going the other way. They already have E, F, and G in log form. Write them out in exponential form. This way is, I think, easier because there's only one way that it works. If you have to rewrite this in exponential form, is it 5 to the 25 equals 2? If it looks silly, it is silly. 5 to the 25th is not 2. Is it 2 to the 5 is 25? No, 2 to the 5th is 32. It doesn't work. There's only one way that works. And what is it? 5 squared is 25. So this 5 is the base, the 2 is the exponent, the 25 goes across. Next one. What's the base when it's not there? Ryan? When it's not there, it's understood to be 10 to the 4th equals 10,000. That's the only way that works. If you wrote 4 to the 10th equals 10,000, that's false. If you wrote 10 to the 10,000 equals 4, that's ridiculous. There's only one way where it actually works, 10 to the 4th. So what about G? Four equals 16 to the 0.5 power. Okay? 0.5 power is the 1/2 power, which we learned earlier in this unit means the square root. The square root of 16 is 4. Okay. Let me go back to the definition real quick. It says here, under definition of a logarithm, A and B both have to be bigger than 0. So here are some things that you can't do. The log of 0, base 9, equals what? It's not 9 to the 0. It's 9 to the what makes 0. It's incorrect. I mean, 9 to the 0 is 1. You're right. So could we do this problem if it looked like this? Yes. The log of 1 base 9 is 0 because 9 to the is 1. Remember, the base goes here, and then the 1 and 0 switch places. That's a true statement. This is saying that what you're logging, this thing here, must be bigger than 0. So what numbers are disallowed, are not allowed? 0 and negative numbers. You can't log a negative, and you can't log 0. They're out. What about the base? Same thing. The base can't be 0. The base can't be negative. The base, logs only work in the positive region. All right? Only log positive bases. All right, that's it for the intro to this, and we will continue at the bottom of the lesson on change of base property in a separate video.